In this section, we are going to learn about how do we migrate for a compute engine session. We'll talk about how to use the Google Cloud Platform virtual machine migration tool. And I've said always, at any time, you can ask questions below the screen. Don't forget to follow the quiz and put the questions on the right side. We will be learning about the compute engine architecture, how to install it in your source environment, the migration process, and some special features like running a test clone. And finally, we'll learn how to use the migration waves to migrate a large number of machines at once. So first thing, let's learn about migrate for compute engine main features. So far, we have learned how to discover your source environment, find the eligible virtual machines to migrate to the cloud. We then learned the fundamentals of the cloud environments. We build on the top of that foundational knowledge. How will you actually migrate virtual machines from your source environment to the GCP? You can have applications, they can start running in Google Cloud just after a few minutes. So there is literally negligible downtime. Meanwhile, all those data transfer that you may have can run in the background in a way that's completely transparent to you, and which kind of helps you to maintain that SLA. You have a built-in testing which kind of makes it pretty fast and easy to validate before you migrate, and then they have fast rollbacks on provide you safety when something goes wrong. And migrate for cloud compute engine provides you with the data-driven right-sizing recommendations to optimize both the cost and the performance. So migrate for compute engine has three major components. We have the migrate for computing manager. We have a cloud extension, which is hosted in the cloud platform, and the backend, which is hosted in your source environment. You can say the manager is a compute engine virtual machine, which is going to orchestrate the entire process and will provide you with awesome web UI. This is the place where you define the migrations, maybe the group of machines that you want to migrate together. The migration for compute and manage it basically connects to your on-prem infrastructure over a secure channel. You can use a VPN connection or some kind of a physical cloud interconnect. This manager basically communicates with the VMware or the vCenter plugin, which in turn kind of communicates with Migrate for Compute Engine on-prem backend virtual machine. And then this backend is basically a virtual machine which is going to stream, or we can say it streams the virtual machine disks in your on-prem data center to the cloud. For example, if your source environment is AWS, then a migrate for compute engine importer virtual machine will be installed automatically in your AWS cloud environment, which is going to provide you the same functionalities as a backend on the on-prem. And every time there's going to be a migration that will be initiated, this manager will create an importer, you can say, in your AWS environment to stream the source virtual machine disk to the GCP platform over secure connection. And when the migration is done, then that import is delivered. So you can see how cool is to the migrate for compute engine done. And if you want to migrate resources, you know that how easy GCP has made this for you. What's a cloud extension? The receiving end of that importer from the AWS or the backend from whatever on-prem infrastructure is that cloud extension. So what cloud extension does is it works with all these components that you've spoken about to create a highly optimized data streaming and caching layer, which is going to be used while the migration is being done on the cloud. Therefore, you will have lesser downtime. So the cloud extension is basically a pair of cloud edge nodes that are built for redundancy in each zone. As you can see here, we have edge node A, edge node B, and then they serve the data to the migrated VM over an iSCSI interface. The next one is the installation process. Now, to deploy Migrate for Compute Engine, what you need is you need to go through a couple of steps. It uses a secure VPN tunnel or some kind of interconnect to connect your source environment. It requires some specific rules that you got to set up before the migration can begin. Once the network is set up, then you will be required to create some roles and service accounts. If you remember, Migrate for Compute Engine can use to create the Google Cloud resources. You can deploy the Migrate for Compute Manager from the Google platform market in just a few clicks. Pretty easy. So you can deploy those appropriate appliances based on the source environment. Maybe if it's a backend system on-prem, you can do the backend on the vSphere or the AWS. You can have an importer from AWS. And to complete the process, you will deploy a cloud extension back at the destination environment to make that process happen for you. Then the process. So once we install the Migrate for Compute engine in the source environment and GCP, obviously that's where the migration kind of starts. The first phase is called as full migration, where you kind of migrate for Compute engine will execute three different steps. The first you can see is run in the cloud. So run in cloud step kind of starts by turning off the source virtual machines. It creates an image. So if you're migrating a Windows machine, then the process will perform relevant adoption to the cloud environment automatically. For Linux OS, maybe some kind of RPM package needs to be installed in advance. Then we have a storage migration, which is going to migrate the full data to the cloud so that streaming is kind of not necessary anymore. And when that storage migration is completed, the migrate for compute engine is going to prepare to detach. It will copy all the cached data from the previous operation to a native compute engine persistent disk. It's very important for you to understand that you can also manually go through each of these phases. Okay, so it's not like you have to follow, you can just do all these things manually, but it's always recommended to automatically execute them sequentially by choosing a full migration. So you kind of don't miss anything in that process. Now, once the full migration is completed, all the reads and writes from the migrated virtual machine will go through the cloud extension, if you remember, in order for not to interrupt that migrated machine operation. And when you're ready to fully detach from the extension, you can initiate that detach step, which moves the remaining data on the cloud extension to all those persistent disks. And finally, shuts down the migrated virtual machine so that it can boot natively and securely from the person's disk. And now it's completely independent and you have a fully working environment on the cloud. Coming from this, when you decide to start a full migration, the first step is called run in cloud. During this entire process, it will shut down your source virtual machine and then it will create a snapshot of its disk. The platform will prepare your virtual machine to run in the cloud and then boot the source disk on a Google Compute Engine virtual machine. And as the migrated destination machine starts in the GCP platform, the data from the source virtual machine will start be streamed now. And it's going to be cached at one of the cloud extension edge node. And then all the communication traverses through a secure optimized VPN connect. So that's how that first step starts. Now, let's say if you are migrating from AWS. So when you run in the cloud process, then migrate for compute engine is going to create a new virtual machine, which is called as an importer in the AWS environment. So which is going to facilitate the data streaming process within the destination environment in a Google Cloud platform. So once your data is migrated to the GCP, you will then delete the migrate for compute engine important VM on AWS because it's no longer needed to stream or transfer data. So there's one more step if you're doing from AWS to create that importer. Now, what if I have some kind of offline migration? So migrate for compute engine. It allows you to migrate workloads running on vSphere with operating systems that are not currently supported by this migrate for compute engine because it's not possible to support all the OS for that. And these are, you can say, typical legacy system operating systems. So during the offline migration process, what happens in this case that all the storage is going to be migrated to the cloud, number one, before the VM starts on the computer. And it's just the opposite of the run cloud, where you have that VM snapshot just again, then the storage starts migrating, streaming. In the offline, it's other way around. So the storage gets migrated to the cloud before the VM starts on compute engine. Then the source virtual machine will be first shut down. Storage will be migrated completely. It will be detached and cleaned up before that VM is going to start in GCP. So we have these legacy VMs that can be migrated to the cloud with the offline migration, even when you have an unsupported compute engine. So you can, as an administrator, you can kind of attach or reattach a data disk to a newer cloud instance to retrieve data from it. That's a pretty easy way. So you can migrate the storage, run a machine, attach the storage, and then retrieve the data from that part. So finally, we come to migration wave. You will now learn how to migrate more than, let's say if I have more than one virtual machine at a time, Then we use something, a feature called as migration wave. Now, when we talk about enterprise cloud migration, we normally don't have a single VM. Enterprise cloud migration offers when you have to move hundreds of thousands of application workloads from on-prem or other clouds into GCP. It's really important to assess your workloads and then batch them into different migration group. And one of the main decision drivers of a migration group is often kind of related to application affinity, where certain system needs to maintain the specific latencies between each other. And in those scenario, you want to migrate these applications as a more of like a migration group. And then this is something we call as a migration wave. So migration wave is basically a mechanism of organizing the systems you want to move into batches, then make your migration strategy more manageable. So one of the most important consideration to think about when you're choosing systems for a first wave is really to focus on that business criticality of the individual workload. We kind of recommend choose those workloads and the systems that are least business critical. And the recommendation would be to migrate your entire application development or test environment first, so you know how process is moving, and then maybe consider your SLAs and uptime requirement from your customer and everything to kind of pay in process. And then also, it's important to consider your workload licensing and compliance requirements too. So a wave is what? A wave is a high level construct which represents the entire migration batch. So when you're migrating a large number of machines, what you will do in the batches. Think about a wave job is once you will initiate a migration, then these are the jobs that will be running on the VMs on a specified network. Now we have a runbook. Now what's a runbook? This runbook is basically a CSV file that specifies the VMs that are required to be included in that wave and all the configurations of the target VM. So it describes the source VM, the properties of the target VM, the network, etc., and all those information that's required. Finally, what's a job? Job is the migration operation that you can say migrate for compute engine that are on that VM runbook list. So their migration operation will include creating the test clone, doing the full migration, and doing the detaching that we do for the single VM. Then we have to do the same thing for those batch VM and the wave VM. And these are same operations that we have learned previously in this section of that. So it's important to understand how we create a migration wave, because when talking about thousands of VMs, then you can't just start doing them manually. That's going to be really tedious, right? Great. So I hope we have understood the whole objective of this module is all about migration by using the Migrate for Compute engine to migrate from on-prem, offline, AWS, and finally how to migrate in bulk. We spoke about the architecture. We spoke about how to install it in a source environment, the migration process, different features of running like some test clone. We learned about finally the migration wave, where if we want to migrate a large number of machines at once from that. So that brings us to the end of this section, and let's right away jump into the next one. All right, so now we are going to talk about governance. One of the most important thing in the cloud management. We have the experts on the standby to help you and then get your answers. Let's get started. In this section, we are going to learn how we create and manage user identities in the cloud using something called as cloud identity. We'll learn about how to sync your current users and the groups from your on-prem environment to the cloud using some automation tool. We'll learn some of the best practices, how do we structure the resource hierarchy, maybe your cloud, if when your cloud footprint is going to grow, how do you manage them? You'll learn about centrally managing a single network across multiple projects, which is also called a shared VPC. And finally, we're going to learn about how do we manage the identity provider across the environments. So the first thing we'll talk about is what is cloud governance? Is the people, process, and technology simple? People, process, technology, which is associated with your cloud infrastructure, all the security and operations. So the governance kind of involves a framework with set of policies and standard practices You define some guidelines about what software applications these people can use, some policies for cloud security, who can access what. And obviously, these rules can be flexible, but there needs to be some kind of approval process. But let's say if you're running some kind of a multi cloud or hybrid environment, we can use some kind of third party also to monitor the solution. So once you understand the governance, now let's talk about the policies and role. The top level node of the hierarchy is the organization resource, which kind of represents the organization. For example, some kind of company. The organization resource provides the visibility and control over all of the resources further down the hierarchy, where we have the folders. You can use the folders to kind of isolate the requirements for different departments and teams. You can use those folders to separate the resources, maybe the production resource or the development resource. And finally, we have those projects, which basically contains the resources like the storage, the networking resources, which basically constitute your application. So what is an organization node? If you remember that we spoke about that the organization resource, they kind of represent an organization, and that's basically a root node in the Google Cloud resource hierarchy. That's like the top, the first thing on the top. So the organization resource is the hierarchical, you can say, ancestor of project resource in the folders. Everything comes under the organization node. And then we have the cloud IAM access control policies that are applied on the organization resource, and they get applied to throughout the hierarchy and all resources. If you have a policy which gets applied onto the organization level, it gets applied to everything which is further down below that. And in the GCP, the organization resource is basically, I would say, the root node of the GCP resource hierarchy. And all the resources that belong to an organization are located under the organization node. So your organization node is automatically created when you have a user which is associated with, let's say, G Suite domain. It creates a project or building account, and each G Suite account is associated with exactly one organization. So all these organizations are associated with one domain, which is kind of set when the organized resources are created. So you don't need to create organization by yourself if you are a G Suite customer, because all those org resources has been provided to you automatically. Now, the cloud IAM that we have, but what it does basically for us, it allows us to set the policies at different level. That means the organization level, the folder level, the project level, the resource level. I mean, there are four levels of the policies. So if you talk about the organization level, we know that represent the resource on the entire company. So you can have the IAM roles granted at this level, and then those roles will be inherited by all the resources under the organization. If you talk about the folder level, folders can contain projects or other folders, or maybe a combination of both. So if you put the roles which are granted at the highest folder level, then they will be inherited by all the projects or other folders which are contained in that folder. And in your project level, which kind of represents a boundary, you can say, within your company. So all the services within the same project will have a default level of trust. Think about, like, let's say you have an app engine instance which can access, let's say, your cloud storage bucket within the same project, so that the IAM roles granted at the project level then are inherited by the resources within the same project. And finally, we have the resource level, I would say, which is a way to where your resources are going to access everything. So resources like data sets or compute engines, instance support, the lower level roles, so that you can actually grant certain permissions to a resource within a project. And now you can imagine the hierarchical order for that purpose. The roles are going to go from the organization to the folder and the project and the resource. And one of the only exceptions, I would say, to this entire permissioning rule process is the organization policy. So we have an organization policy which kind of gives you a centralized and pragmatic control over your organization cloud resources. So you can have the policy on the org level, and no resource within the org can be provisioned, and it's applied at the root of the resource hierarchy, and then restrict the access to resources across all the descendants. We have an organization policy administrator. We define a policy, it's set on, and it goes to the resource hierarchy node, and it's inherited by default to their folder or their project, and then goes further from the top to bottom right. So each binding, the binding is white, like one or more member, like that's what binding means, right? When we talk about binding, we have something called as member, your identity or principal. It's anyone who's going to be the user account in that case. The role, we know that's a set of those permissions which will be granted to perform actions on the Google Cloud resource. Then we have a condition, which is the logic behind the role of binding assignment and how that's going to work. This example policy on the screen is set at the organization level. So if you see, we have a storage object viewer role, which is role slash storage dot object viewer. It contains the get and the list permissions for projects and cloud storage objects. When it's set at the organization level, what happens that the role binding is then applied to the levels under the organization, which will include what? You know that includes all the projects and all the storage buck objects under those projects. So you can now imagine that it's pretty easy. So let's say if I want to apply a policy at the organization level, I know it's pretty easy for me to do that because now I can just put a policy and then it will be inherited by all the further down below hierarchical requirements that we have. There are different organizational policies that you can have, compute engine, IAMs, GCPs. So there's so many ways that you can really have the policies implement to have a standard maintained across your entire GCP ecosystem. And that's what these policies does for you. Now, what could be a resource hierarchy? Now, Google Cloud Resources, we know they are organized hierarchy where the organization node is the root node in the hierarchy. The projects are the children of the organization, and then there are other resources, which are basic descendants of the projects. If you think about this example here, we have the organization, we have the folders, project, and the resources. So in the organization level, it represents the company. So anything which gets granted this level are going to be inherited by everything else, which is the folder project level. Any policy gets put at the folder level will get entered by its subfolder of the project. Anything gets created at the project level will get entered by its resources. And in the resource, you can have some lower level resource that you can grant certain permissions to. Think about a scenario where many users are uploading files to a bucket, but they shouldn't be able to read or delete any of the files which are uploaded by a user. So your data processing expert should be able to read and delete uploaded files, but they shouldn't be able to delete buckets because others are also using the bucket location to upload their files. And then in the scenario, what would you do? You would set policies. Maybe you will grant the storage object admin role to your data processing expert so that that specific individual has the object admin rights at the project level, can read, add, and delete any object in the bucket. Then we have authentication. Now, remember we spoke about the IAM before when we touched the cloud identity. Now, what cloud identity does, it handles the authentication for us. The way it handles authentication is that it's identify a user typically through some kind of verification like a password and a key. And cloud identity is actually managed outside of Google Cloud Platform in something called admin.google.com. It's like for a G Suite to do that. Now, I am, in contrast to, is kind of responsible for authorization. So your cloud identity is there, it authenticates where I am kind of authorized, which is a set of permissions that a user is allocated post that authentication done. So if I have a user in the cloud entity, I have a user like Vishal who has permissions to create a compute engine. So Vishal as a user is authenticated with the help of cloud identity. Vishal is going to be authorized to do something on the compute engine is the authorization, which is the permissions that I have assigned to this user. And those permissions then are managed directly inside the Google Cloud Platform console at the cloud.google.com under the IAM section. Now, in the IAM, we have the roles because when you start creating your cloud environment, you need to establish who in your company can have the permissions to create or access or modify or destroy resources. And there are a few things a few key IAM roles that it's always recommended that you should always pay close attention to. One is obviously the admin role, which is responsible for defining those IAM policies, determine the resource hierarchy, delegate the responsibilities over critical components. It's always worth remembering that you only get an organizational node, a folder structure, and an organizational admin if you import your domain to Cloud Identity or a G Suite. And having an organization in GCP is not mandatory for a virtual machine migration, but it's always recommended for scalability reasons that you would have in that case. So this is how the IAM roles are responsible, and that's how you can see why they're part of the governance in that system. Now, how do we do the account synchronization? When you migrate to the Google Cloud Platform, there are different options that you can choose from managing the user's lifecycle. You can start by creating few users in an environment, and which can be tedious, error prone, but not scalable. Obviously, you can import a CSV into maybe a cloud identity, and then after the operation, the user's lifecycle does not sync with your source environment. And there's a way to create a trust relationship between your directory service and the cloud entity, and that's called as Google Cloud Directory Sync. So, what is Google Cloud Directory Sync? It's a Google provided connector tool which integrates with most enterprise LDAPs, managed systems, and it kind of helps you to synchronize the identities on a schedule. It runs on a dedicated machine on the on-prem, and what it does, it communicates with the cloud identity with all those relevant protocols. So the GCDS is a one-way sync tool, which keeps your user or your on-prem Active Directory as a single point of truth for all those authentication. It synchronizes the users and group in order for them to use the cloud environment with the same credentials that they would use always on the on-prem. It gives you a granular control over the corporate users that you want to grant direct GCP resources to, and that's a great way because you would now not be copying the users on the cloud console, manually. Now, the GCDS only syncs objects. Always remember, like the users and the groups without their passwords. So once we have a user which is synced to the cloud identity with GCDS, it needs to also have a password, right? Or mean some kind of authentication. There are a few options to choose from. The first one is to create a password for the users in the cloud identities admin console. Then the user will authenticate against the cloud identity, and their cloud password is not going to sync back to the Active Directory. Now, an alternative is to set up some kind of an SSO, maybe using SAML2. I mean, then there are two options. The one is that to use a cloud identity which is managed and highly available service, or you can federate the authentication of your synced cloud user back to on-prem. So if you're configuring SSO, the user will be authenticated directly against your on-prem identity provider, which eliminates the need to manually manage the passwords in the cloud, which means that your on-prem identity provider must be highly available to user all point of time. It's very important to have this thing. Now, federation is something before you really begin, you got to understand how Active Directory management system can be extended to Google Cloud. There's great docs to read about that. You want to decide how you want to map identities and groups and domains specifically. Make sure that you've answered all those relevant questions that you have for yourself, like which DNS domain do you want to plan to use, or do you need some kind of domain substitution or check like that. And before connecting your production Active Directory to Google Cloud, it's always important to consider using an Active Directory test environment to set up and test if everything is working as planned. And then you can decide where do you deploy your GCDS. You want to decide where to retrieve the data, and then finally prepare your cloud identity or G Suite environment where you can create a user for GCDS, and then configure the user provisioning, install GCDS, create folders for GCDS configuration, connect it to Google, and finally you connect it to Active Directory, and therefore you will decide what to provision the users, and that's how the process. Very, I would say, not that tedious as it may sound like. Now, one of the things, if let's say you not use SSO, right? And you would like to sign into Google Cloud Platform with the same password that you use on-prem. Now, how do you do that? There's something called as G Suite Password Sync, which will also synchronize your password from the Active Directory to the cloud identity in a real time. So it's also a great thing to say, hey, we don't want to use a new password. How do we sync the on-prem to the cloud? That's where you will use the GSPS, which is G Suite Password Sync. So GSPS, what it does, it will intercept the raw password and then apply a SHA-512 hash before they're actually transmitted over an encrypted TLS channel. So your passwords are never exposed to anyone on that transit that's happening. And then only a solid version is kind of sent to the cloud identity using some native APIs. So those are great features that you can use to kind of sync the password, right? Great. So now we've understood how do we sync the users. The next thing we want to talk about is the resource management, how the resource management really operates. So as a scale of your cloud footprint is going to increase and increase. Obviously, there will be more need to organize your resources into folders and projects, increase for billing, administrative, security, and a lot of things that happen. And then you have to segregate your resources in a way that makes sense for your organization. It allows helps you kind of put policies in place, separate those administrative boundaries, fine grained control over consumption. So as a resource hierarchy grows, more and more projects and folders will come up there. And there are a few common resource hierarchies that we recommend you using. I mean, when you start using GCP, you may start with a single project. And as more teams and products areas start using cloud resources, the number of project will you own will grow. So in those cases, it's always recommended to use folders to organize these resources, which kind of helps simplify the access and permission pattern. For example, let's say um, in this hierarchy, an organization decides to segregate the resources based on the environment. Maybe a folder for production and a QA and dev. And there are some engineers in the company which have full control over the dev folder. Therefore, all the project and resources under it will have maybe if you only access to production. You can have a more complex example as where you have some kind of a function-oriented hierarchy, which has, let's say, two layers of folder, one for the environment, one for the functions of the business. And that makes the access and the permissions more granular. So it's always a great practice to define the right organization hierarchy to make your life easy, else you will always be kind of having a hard time to manage the resources. And that's as a recommended practice, you should always and always and always work in that model. Resource hierarchy is a very important thing that you should always keep a track of it. You should have an organization resource, always link your G Suite or cloud and accounts. And there are different benefits of organization resource. I mean, um, an organization resource is already exposed by resource manager API, where you have the organization ID, a display name, the creation time, etc. And you can use these details for that. You can have folder resources, project resources, you can have it, and you can have the IAM policy inheritance, as we spoke about. If you apply a policy at the organization level, it's going to go drill down to the bottom of the level that's there. So there are different ways to um, kind of have these resourcing done for you. So once we have this, this next thing is very important. Is like how do we provision a shared VPC? Now, shared VPC, it allows an organization to connect the resources from multiple projects to a common VPC. So when you going to use the shared VPC, you basically designate a project as a host project and then attach one or more service projects to it. So what's a shared VPC? Now, in this diagram, the shared VPC admin configured a web app project to be a host project, which has some subnet level permissions. It allowed the shared VPC admin to selectively share the subnets from the VPC network. And then what's happening that each project owner is going to create the VM instance from their service project. So now you can see that a shared VPC admins will have a full control over the resources in the host project, including the administrations of the shared VPC. They can delegate the network admin and security roles for the host project. Now, project that participates in a shared VPC is either going to be a host project or a service project. A service project is going to be one that has been attached to a host project by a shared VPC admin. And finally, we're going to talk about managing the identity provisioning. So we've introduced a way to manage the life cycle of a user. So VM on-prem, they kind of tend to authenticate against what? Against LDAP, right? Or a similar directory service platform like maybe LDAP or NES. But when you migrate VMs to cloud platform, then your virtual machines still need to authenticate against an identity provider. And there are few choices to choose from. Each has own benefits. You can connect your or you can when you migrate your VMs to Google Cloud, these machines can authenticate again using your Active Directory on-prem or maybe an Azure Active Directory server. It is suitable in situations when your cloud footprint is really very small in comparison to the source environment. And the advantage of the strategy are that there would be like little to no application or virtual machine changes, and it's going to save a lot of time because you don't have to move your ID provider. The disadvantage would be the trust boundary of your Active Directory is now kind of extended to include your cloud environment, which needs to be hardened, else there would be some security issues in that case. And you're kind of dependent on the interconnectivity between the two environments, whether the connection to the VPN channel or some kind of physical cloud interconnect. So if you choose this approach, you got to always ensure that the DNS entry resolves correctly, and remember that only one global domains are allowed in that case. If not this, then what? If you move all of your workload to the cloud, you can simply move your Active Directory also while you keep it that on-prem. And the benefit of the approach is that it's usually a simple process, unless you have a high availability configuration in place, which can make it slightly more challenging. So if you do not have workloads that's on-prem, then these workloads need to authenticate against a remote server. So moving your Active Directory to be a cloud, I would say, is one of the preferred solutions. I have done a lot before, but you still have to kind of maintain in that case. Managed service for Microsoft Active Directory is a very high available hardened Google Cloud service running an actual Microsoft Active Directory, which allows you to manage your cloud-based Active Directory workloads. And there's no need to learn new tools. Your organization can still use Active Directory features like group policies or all those tools like the RSATs, if you're aware about that. And with the managed service for Active Directory, you can really connect your on-prem resource. So you know that how easy now it becomes that to connect and migrate your on-prem resource to Google Cloud, connect your current Active Directory environment, even create a new one, and then be ready with that. And that's all we kind of have to do in the governance period so that we have the governance ready for us. So in this section, we have learned how do we create and manage the user identities in the cloud using the cloud entity. We've learned how to sync our users from the on-prem to the cloud. We've learned about the Active Directory, how we can use that, different authentication mechanism. We've learned how to manage a single network across multiple projects using the shared VPC concept. And finally, we've learned how to manage an identity provider across environments. And that brings us to the end of the section, and let's move to the final section for today. I hope you are enjoying it, and feel free to ask as many questions as you can. Finally, welcome to the last section for today, logging monitoring. In this section, we will learn about how do we use a stack driver monitoring and logging capabilities in order to give you more observability about your cloud environments. We will also learn how do you manage the instance groups, which are automated virtual machines, and we'll learn about the cloud load balancers and future stuffs. The first thing we will be learning about is the stack driver monitoring. So what is it? Measuring the system and infrastructure, it always a great importance of practice. You got to know how your infrastructure is behaving, how the resources are behaving, how what kind of traffic is coming out, what kind of traffic is going out, all those details, your vcp utilization, your memory allocation. These are all your low level indications at the base of the pyramid, as you can see, which comprise a part of the system and infrastructure. Now, the system and infrastructure layer function is to run the application, which sits on the top of them. And monitoring the application layer provides you a holistic picture of the, you can say, the health of your workload. For instance, you measure the CPU utilization and the memory allocation of the database that can provide you partial indication of the health. You can measure the metrics like query latency provides, etc. Finally, if you look at the top of the pyramid, are your the business process. your applications and platforms are eventually there to answer business needs. What StackDriver does you, it gives you the observability of all those three layers that we just spoke. It's a GCP fully managed, you can say a native login monitoring tool. It gives you access to logs, metrics, traces, all those signals from infrastructure platform, VMs, containers, middleware, application tier, you name it, they have it, so that you can track issues all the way from your user end to your user backend service. So Stackdriver, what it does is it kind of aggregates the metrics, logs, and the events from the infrastructure, and it gives the developers to operate a rich set of all those observable signals that kind of speed the RCA. Something goes down. How do you find that? That's what Stackdriver helps you do that. It doesn't require, I would say, an extensive integration or multiple panes of glasses to kind of look what's going wrong. It gives you great tools of resources to monitor everything that you would have in the case of the GCP. So what Stackdriver does, it configures the monitoring once a resource are deployed. For example, once we launch a GCP virtual machine, we have a monitoring resource which can detect the number of ingress and egress traffic that has coming to our machine in that case, which allows you to help, and it helps you to create chats for monitoring activities. You get some great rich visualization and advanced alerting, which helps you to identify the issues quickly. If there's something like, let's say you're finding that your CPU has a spike of maybe 100%, then you can find that on the log, what's happening. You can figure out and look at those graphs and see if something's not wrong, which allows you to um, monitor your platform systems and all those metrics by ingesting data like the metrics or events. And you can then generate insights from that data with the visualization, use that data on the data studio if you want to look at that. Now, we have something called as a workspace in the case of Stackdriver. Now, what is a workspace? Workspace is your single place where you can deploy everything, because workspace can monitor all your GCP project in a single place. You can say workspace is a single pane of glass through which you can view resources from GCP multiple projects and AWS accounts also. And all Stackdriver users who have access to that workspace, they have access to all data by default. That means that a Stackdriver role assigned to one person on one project, it kind of applies equally to all projects which are monitored by the workspace. So if you want to give people different rules per project and you want to control the visibility to data, then I would say consider placing the monitoring of those projects into a separate workspace so that they can be separated in that case. If you look at this thing, now you can understand that your workspace is basically the root entity which holds the monitoring and configuration information in Stackdriver monitoring. And each workspace can have between 1 and 100 monitored projects for that purpose. And you can have as many workspaces as you want, but the GCP projects and the AWS accounts, they cannot be monitored by more than one workspace. So if you have one workspace, only one account can monitor those GCP project and AWS accounts. So your workspace now, you can imagine it contains those dashboards, those policies, the checks, notifications, the channels, groups, the group notification that you can use to monitor project. Everything is a part of the workspace. It can access those metric data from the monitor project, but the metric data and the log entries, they kind of remain in the individual projects. And the first monitored GCP project in a workspace is called the hosting project, and it must be specified when you create the workspace. And the name of that project becomes basically the name of your workspace, in this case, which is Workspace Z, as you can see here. And then to access an AWS account, then you have to configure a project in GCP, which is going to have that AWS connector by which that AWS account will be monitored. So your Stackdriver can actually monitor your AWS resources too for yourself. The monitoring can access all those lower level metrics without the monitoring agent, which includes the CPU utilization, then disk traffic, or network traffic. I mean, for that you don't need any kind of monitoring agent. But let's say when you're looking for additional system resources and application service, then you will need then there's a need to install the monitoring agent. And Even in AWS, there's an option to kind of have monitoring agent to get installed on the EC2 instances. So that's something that you would be required if you need additional information more than what's provided default. You can also have your custom metrics. Let's say if the metrics which are provided by a Stack driver are not fitting your needs, then you can create your custom metrics. This is an example, as you can see, of an HTTP uptime check. Now, what is happening here? The resource is being checked every minute from 6 different locations across the globe. Each uptime check is then configured with a timeout period, and checks that do not get a response within a timeout period are going to be considered as failure and an effective uptime person. That's one of the examples that you can see how the stack driver kind of really operates. It's really cool to do that. We'll see how the stack driver logging operates. So what stack driver logging does. Until now, we have understood the stack driver monitoring, but logging is where you store and search and analyze and monitor and alert on log data and events from a GCP and AWS. So it's a fully managed service that performs at scale. It can ingest the application and system data from thousands of VMs. So if you have a logging enabled, it can store. It can be used as storage for logs. Maybe a user interface called as log viewer is there. You have an API where you can manage the logs programmatically also, which as a service allows you to read and write the log entries. Whether you're running on a GCP or a AWS or on-prem or even a hybrid cloud, what Stackdriver does, it combines a lot of metrics and the metadata from all the cloud accounts that you have and projects into a single comprehensive view of your environment so that you can quickly understand the service behavior and take actions. And finally, as I said, Stackdriver supports a rich and a growing ecosystem of technology integration to expand the idea options. You can see there are a lot of services which are supported by the Stack driver and a lot of partner integration that it has. So it's one of the great monitoring feature that you should always leverage and use in that case. The one thing which I really want to talk about now is the managed instance group. What a managed instance group is, let's say you have migrated your virtual machine in the cloud. It's time for you to leverage elasticity, like the automation, the high availability, all those things. That's why you move to the cloud, right? So let's say some of your workload is capable of doing a horizontal scalability. Think about like a web server or some kind of state application. Now, when the demand is going to fluctuate, you ideally want to have the right amount of servers operating to serve your user. In that case, the first step is we do is create an instance template, which is nothing but the blueprint of the machine with all those pre-existing configuration like the machine type, the boot disk image, the startup script, all those properties that makes that specific instance running. So maybe your boot disk image could be a pre-configured web server image, and you can have a startup script that can start a service as soon as the machine starts. You can have a template and let the template be used every time there's some kind of horizontal scalability is required, and you can just launch a new instance right at that moment that's required. Once you have this, you can see we have this server template by which you are able to launch the server 1, 2, and 3. It's pretty easy to kind of scale up in that process, and you can see that it's now available, and as the requirement grows, it deploys the identical instance based on that template we just created. So every time there's going to be need for a new server, it's going to be exactly same as the one that's running for us. And if you see in this case, when it's time to update your application or change the configuration of your machine in the instance group, then you can also create a new instance template and kind of roll out an update with no downtime. As you can see here, you have the version 1 on the right, and then there are updates happening. The version 2 is kind of rolling up, and update work is then going to replace a subset of machines from the group gradually until all of the machines are created from the new template. And this strategy really ensures the continuous deployment process, which is CI/CD, and there is a very minimum service interruption downtime. And that's kind of does a process. And now, once you have a lot of resource, a lot of VMs you have, you want to still load balance the traffic, right? And that's where we have the global cloud load balancing, because all these managed instances, they can work with load balancing service in order to distribute the traffic across all the instances in the group. And that way, what happens, your instance group can be accessed using a single internal external IP. um, We have regional managed instances that are kind of general recommended over zonal managed instance group. You use a single, anycast IP address. Now, cloud book balancing is you can say is a fully distributed software defined managed service which is going to direct traffic to your instances. And because the load balancers do not run the VMs, you have to manage and don't have to worry about scaling or managing them. You can put the load balancing in front of maybe an HTTPS and SSL traffic. And with cloud load balancing, um, a single Anycast IP front ends kind of all of your backend instance or regions. So you will get one single Anycast IP, and that will uh, put the traffic to all of your backend resources. It provides your cross-region load balancing, have a multi-region failover, which kind of shifts traffic to only healthy instances if the other ones kind of fails over. So, and the cloud balance is going to keep checking the health of all the resources at all point of time. It includes the number of users, the traffic, the network, the health, and all those conditions. It reacts quickly to all those changes there. And what if you anticipate a huge spike in demand? Let's say your online game is already a hit, and do you need a file support ticket to kind of warn Google of the incoming load? No, no. So-called pre-warming is required in that case. So there's no pre-warming in that case is required. You can tell, hey Google, I'm going to have another 1 million users. You be ready. No, you don't have to do that. Your load balancing will kind of take care of that part for yourself. Finally, the cloud support. So there are two support plans to choose from on the Google Cloud. One is role-based support and one is enterprise support, and both offer kind of one-on-one technical support for all kind of outages or any defects or any expected product behavior. Now, when you use a role-based support, you can configure your support to match your exact needs with the development or production rules. For example, let's say you are in a developmental stage of your cloud solution. You can rely on that relatively slower support software, which offers a more economic support plan. So if you're running a live production support, and your production team obviously might encounter issues that require fast solution, which is where you have a production support tier involved in that case. And all support access is kind of paid per month with no long-term commitment. And it's a flat rate rather than a percentage of your cloud spend. And then there's also a free basic role that offers read only. If you want to reach to Google Cloud, there are all the different ways: a free development and a production, where you have different SLAs responding to those requests, depending upon the scenario that you're really going to build in your support. And then finally, we have this enterprise. Let's say you're running mission critical application, you need support ASAP. In an enterprise environment, then you have the enterprise support, which is a suitable plan. It has unlimited support contacts, a faster response time. If you have a priority one case, you're looking at less than a 15 minute of response time. It's worth noting here that the support case management in the Google is kind of integrated with the cloud console, with the user management kind of built on the cloud identity and access management for the enterprise grade access control. So it's very important too for you when you're able to really build an entire system on Google Cloud. You should know something goes wrong, how you're going to reach to this Google Cloud support for the different purpose. And that's also part of the monitoring activities. You've got to monitor and you got to understand how those things should work. How do you reach out to the relevant people? What have we learned in this section? We learned about the monitoring capabilities using the stack driver, monitoring and logging capabilities. We learned about how do we use managed instance group, why there's a need for them, and finally we learned about the load balancing solutions on the virtual machines, and we learned about the cloud support tiers.